Section 2.5. A pyramid is 890 feet high and has a square base of side to 6,230 feet. Find the work to build it if the density of stone is 240 pounds per feet. So in order to find the work, we know the formula work equals F times S. And so the distance is just the height, but again, different height, we have different force because it's a triangle, it's not continuously distributed or uniformly distributed. So we need to find the force and the distance. We know we need to use integral. Now, how to find the force? It is the volume times the density. And we know density is 240, so we just need to find the volume. How do we find the volume? And again, we need to know we don't just find the entire volume of the pyramid and then times the height. And the reason is you have less stone on the top than how much stone in the bottom. So the way we need to solve it is we need to break it down into a small layer. So right here, I have a small layer right here. And how do we calculate this layer? If you break it down into a very small layer, okay, you can treat it as just a rectangular, okay? So it's base times height. So in another word, we need to find the side length S of the square. Okay, so how do we find S of the square? So this is S, each layer, and how thick it is delta Y. It's very small. That's how we can treat it as a rectangular. So how do we find it? We need to use similar triangle. Okay, so if you take a look, and Y is the distance that you move up. Okay, so if you move Y feet up, what is left on the top is H minus Y. So we can say, okay, in the very bottom layer is 6,230. Okay, so 6,230 divided by S. Okay, so this ratio should be the same as the total height, 890, divided by 890, subtract Y in our case. Okay, so the H here is 890. So this is the setup of our problem. And you can solve for S, cross multiply, solve for S. It tells you that S will equals 6,230 subtract 7Y. Okay, you can do the calculation. So in that case, we do have the base. So the volume is base. Okay, so this is one side of the square. We square it to get the area of the square times the change in Y to give us a volume. Now we have the volume. We need to find the force. And the force is just the density. Okay, 240 times the volume. And that is F, okay? And we know that Y, okay, Y is, you can treat it as the distance. In this case, maybe I shouldn't use that S, but this S is different from this S. S stands for the distance. So what is the distance? And when we are talking about the height, okay, so the distance, F times S, in our case, is Y because we're moving up and down. So this is our F times S and then we need to take the integral. So the work will equal the integral of 240 times 6,230 minus 7y squared times y dy. Okay, delta y equals dy in our calculus convention. Now, what is the limit? And since I use y, you might know the pattern. Y stands for vertical distance. So it should be from 0 to the top, so 890. And you can verify as y get bigger, f gets smaller, because there's less material on the top. So you use your calculator, or this is just a polynomial that you need to integrate. Okay, so you should be able to do it, and you use a calculator. You should get 6.14874 times 10 to the 14, and the unit is foot pound. Okay, because it is foot and then pound in our cases. So that is it for this problem.